All right, so we're going to do some more related rates today. And these are a little more difficult than the ones yesterday. But the steps are going to be the same. So let's see if we can check it out. It says water is pouring into an inverted conical tank, a right circular cone with a height of 16 and a base of 4 at 2 cubic meters per minute. How fast is the water level rising when the water in the tank is 5 meters deep? So the first step was to get our picture. So in this one, we're going to have a conical tank, so an inverted cone. So think of like a ice cream cone, I guess. And what did it say? It says a height of 16 and a base radius of 4 meters. Now I can label that on my chart, or on my picture rather, because the container itself is not getting bigger or smaller. So those are constant. So remember, we don't put numbers on our picture unless they're constant, but those are constant. And then I'm going to draw a snapshot picture of what's going on. Water is pouring into a cone. So the water level, what's going on is I start to fill that. Of course, I have water in a certain amount of it. Well, this radius, that R, and this height, I'm going to label because that's not constant. The radius and height of that water is what's changing. So there's my given. Now it says that water is being poured in at 2 cubic meters per minute. Again, using our units, cubic meters would be volume. And the volume is increasing if you're pouring water in. So that's going to be 2 meters cubed per minute. How fast is the water level rising? So what is that talking about? They're asking about the change in the height. So find dH dt when the water in the tank is 5 meters deep, so when h equals 5 meters. So that's my first step. Now the second step is to write the relating equation. Good news is that is not one that you have to memorize. They would give it to you. So I would have the volume equals 1/3 pi r squared h. Now right at this moment I have a decision to make because I know I need to take the derivative. I have two variables on the right. If I did the problem right now, I would have to do the product rule. Now, I'm not saying I couldn't do that because you had a homework problem last night. They gave you all that information, you did the product rule and got it. And I could technically do it that way. But, it would be so nice if that volume was in terms of one variable. And if you have a container that's not changing and they give you dimensions of it, that's what they're giving that to you for. So let's look over here. Wouldn't it be true that the proportion of the radius and the height of the water is going to be the same as the radius and the height of the container? It's always going to have that same proportion. So if I solved, now which one do I want to solve for? Well, all these have h. Find dH dt. So I want to leave h. So I need to get r in terms of h. And so here's what I'm going to do. I'm going to take this r and watch what I do to the relating equation. So I'm doing some stuff with this before I actually take the derivative. See how I replaced? If you look at what I have in pink, everything in pink is what I had in the line before, but for R, I used this statement. Now, if you're going to go to all that trouble, by all means, clean that up. So the volume is going to be, you got to square the number as well, so that's going to be 1/16. 16 times 3 is 48. Pi, and then you have h squared times h, that's h cubed. So there was work to do in the relating equation before you actually use it. Now let me take the derivative. Now I'm ready, and the derivative is so nice because it is one variable. power to the front, I tend to clean up as I go. And again, I'm not using a calculator because I want to prove to you that you can do it without. Power to the front, if I clean up as I go, 3 over 48 is 1/16. Pi h squared dh dt. And let me start filling in. We've got 2. We've got 1/16. We got pi. We got 5 squared dh dt. And so let me just think about that. Dh dt is going to be what? Well, I'm going to take that 2. And what I really have on this is 25 pi over 16. So I'm going to multiply by the reciprocal. So I have 2 times 16 over 25 pi. Obviously, I could write 2 times 16 as 32. But here, I want to make a point with these. And so here's the deal. 32, 25 over pi. I'm going to be honest with you. On the AP exam, on the free response, they would accept all of those. Now, I have to put units and I have to, do my notation and stuff, but as far as the number, they do not care if once you get down to multiplication, addition, division, and subtraction, you do not have to multiply it out. Now, obviously for the purposes of us and our test and your homework, we're going to simplify because it's just easy to see your answer. And also know that this could be on multiple choice. And if it's on multiple choice, they are going to write the most simplified answer. So you need to practice that as well. So here's how I would finish that problem. Again, writing it like I did yesterday. When the water is 5 feet deep, or not feet, sorry, 5 meters deep, the water level is rising at a rate of, and I'll go ahead and write the pretty version, 32 over 25 pi. What are the units? Well, what would you be measuring h in? That's the height of the water, so that would be meters. And the unit of time was in minutes, so meters per minute. Now, let's say this is on the calculator part. So this is just kind of a side note, because again, it could show up on any part. And I just want to make sure when you type, let's say you get down to this on the calculator, you need to make sure that you are using the alpha y equals and get it as a fraction. Because if you type it in like this, 32 divided by 25 pi, and that's what you type in, you are going to get a wrong decimal. Because your calculator does the order of operations, it does this division, then multiplies by pi. And that's not what you want. So if you hit alpha y equals, when you do that, you have the option of having, the very first one says n over d, and that's what you want. And then your calculator will set up a fraction and it looks literally just like this. So that is my hint on a calculator portion for you to get the correct decimal. And just for the purposes of your homework, because let's be honest, typing all this stuff takes a long time. It's much easier to write the decimal. I'm going to put, even though I'm not using a calculator, I will put the decimal value, and that's going to be how you check. So you don't necessarily need to use a calculator, but except for the very last step when you're plugging in to get the decimal to see if you have a right answer. So that is the cone problem, filling a cone or water going out. Let's look at the ladder problem. Okay, we got a ladder 26 feet long leaning against a vertical wall. The foot of the ladder is being drawn away from the wall so that the ladder is sliding down the wall at 2 feet per second. How fast is the ladder being pulled away from the wall when the foot of the ladder is 10 feet from the wall? Okay, a lot of words wall in there. Well, let's get us a picture. So, very exciting. Wall. Ladder leaning against the wall. A ladder 26 feet long. The ladder is not growing, so I am going to write that constant. The foot of the ladder is being drawn away from the wall. So sometimes, again, they don't grade your picture. I kind of do this so I understand what's going on, so that the ladder is sliding down the wall. So kind of it's visualized going out this way, and then this part is going down. Now I'm going to put some variables on there. So the foot of the ladder is a certain distance from the base, and I want us to put X, and I'm going to use Y because I want to make a point about the X. And so Y is, of course, the distance from the floor to the top of the ladder. So let's put, using those variables, let's put, write our given. The foot of the ladder is being drawn away from the wall so that the ladder is sliding down the wall at 2 feet per second. Now, if you're saying Y is the distance from the ground to the top of the ladder, is Y increasing or decreasing? Well, if the ladder's falling down, Y is getting smaller, which means your dy dt, you need to put in that negative number. So you get negative 2 feet per second. How fast is the ladder being pulled away from the wall? This is where it's being pulled away. So find dx dt when what? The ladder is 10 feet, when the foot of the ladder is 10 feet from the wall, so that's when x is equal to 10 feet. Perfect. Now let's do our next step. Our next step is to write the relating equation. What is the relating equation that relates your picture? Well, hopefully you're like, well, x squared plus y squared equals 26 squared. I don't have a calculator, so I don't know. I'm not going to get what 26 squared is. I'm just going to write that. And the good news is I can then take the derivative. And I wanted to use an x so that it's very common for people to forget the dx dt. Because they're like, oh, the derivative of x squared is 2x. Remember, with related rates, you're taking the derivative with respect to time. So you have to remember that every variable has a, dx dt or dy dt. One of the most common mistakes is that right-hand side. People put that number. You're taking the derivative. The derivative of any constant is 0, so that goes away. Now again, I'm not doing this with a calculator, so I always look to make my life easy. They both have a 2 on them. I have an equation, so I can just cancel out those 2's because I could think to myself, okay, let's divide everything by 2. So I cancel those out, okay? I write them when I write the derivative because they're going to grade your derivative. But I then just go, oh, let's cancel those out. So let's start plugging in. I'm finding dx dt when x is 10, so sweet, x is 10. dx dt is what I'm finding, so it makes sense that I don't have that. Plus, and then I get to y, okay, let me skip that for a minute because I don't have that. What is y? dy dt is negative 2. So notice what tripped me up was this y. Friends, after you've taken the derivative, if you start filling it in and you are missing a piece that you shouldn't be missing, in other words, you're finding dx dt, so it makes sense that I don't have that. I wish I had y. If you don't have that, they have given you enough information to find it. Let's go back, and some people write it under here, you're given. Some people do another picture. I don't care where you write it. Over here at this snapshot moment, when x is 10 and y is 26, could you figure out what, when x is 10 and, the ladder is 26, can you figure out what that distance would be? Well, of course you could, because you could do 10 squared plus y squared is 26 squared. And that's a version of a special right triangle, those Pythagorean triples there. And so y is going to be 24. And that's what you fill in here for the y. They've given you enough information to get that. I still have the equal 0. So let me finish the problem. I can visualize it in my head. I can say, okay, if I'm solving for dx dt, this negative 48 is going to go to the other side, so it's going to be positive. I'm going to divide by that 10, so of course I get 4.8. So I could write my statement. I'll write it real small right here. When the foot, I didn't leave enough space here, foot of the ladder is 10 feet from the wall, the foot of the ladder, I'll just put the foot, is being pulled away at a rate of 4.8. What are the units? X is in feet, time is in seconds, and I'm done. Now, if you forgot to put that negative, you would end up getting a negative for the answer. And hopefully, that's why I always ask you, but when you look at your picture, ask yourself, is X increasing or decreasing in the problem? X is increasing, so dx dt should be positive. Y is decreasing, so dy dt should be negative. All right, we've got one more to do, and we have the shadow problem, okay? The good old shadow problem. So read that. Okay, the girl's 5 feet tall, walks at a rate of 3 feet towards a street light that is 14 feet above the ground. At what rate is the length of her shadow changing when she is 8 feet from the base of the light? At what rate is the tip of her shadow moving? Okay, so let's talk about she doesn't have a name. We'll call her Lucy. Okay, so she is walking toward a street light. So let's do your picture. Here's the street light. It is 14 feet tall. And Lucy, here's Lucy, who's 5 feet tall, is walking this way. It says toward the street light at a rate of. So they're telling me how fast, so the rate that you're walking as your change in position. So once again, I need to put a variable right there. I'll put that as x, good enough for me. So you know that dx dt, well, is x getting bigger or smaller? If she's walking toward the light, x is getting smaller, so dx dt is going to be negative 3 feet per second. Now, what does the question ask? At what rate is the length of her shadow changing? Well, guys, if this is the light right here, bing, where would her shadow be? Well, her shadow would be right here on the ground. This would be her shadow. The purple would be her shadow, and this is the length of her shadow. So how am I going to do that problem? Well, let me finish right my given. Find dl dt when x equals 8 feet. People always make this problem harder than it is. Y'all, if it's the shadow problem, you are going to make a triangle out of it like that. And you are going to look at similar triangles. Look at this small triangle here. Boom, boom, boom. And then look at the big triangle. They're going to be proportional. Okay? So in part A, again, really this is part A. Part B, same given, but you'll be looking for something else. So I'll just put that there. Couldn't you say that 5 over L is equal to this length over this length is 14, look at the big triangle, over what? Now be careful, it's this whole side, so x plus L. Now I want to take the derivative. Am I going to do it in that line? I wouldn't. I would clean it up. So 5x plus 5L is equal to 14L. So 5x is equal to 9L. You could divide by the 5, you could leave it like that. I don't care which one, but the point is the derivative of this line is much easier than the derivative of that line. So 5 dx dt is equal to 9 dl dt. So I'm looking for dl dt. So I'm going to have 5 over 9. If I divide by 9, I'm going to multiply by dx dt, which is negative 3. So I'm going to get, I'll go ahead and simplify, 3. So I'm going to get negative 3/5. Now what's weird about this one than any problem we have done is that you go, man, I didn't even use that. What does that mean? That means that this number is actually a constant rate. It doesn't matter where you were, you are walking, or the length of the shadow is decreasing at that rate. Now be careful, it's negative because why? It says, how is the shadow changing? So what does that negative mean? It means the length of the shadow is decreasing. That negative means the length of the shadow is decreasing at a rate of 5 over 3 feet per second. Again, could you say changing at a negative rate? Yes, you sure could. Perfect. Now part B. I'll do part B right here. At what rate is the tip of her shadow moving? So think about it, as she's walking this way, this tip doesn't stay right here. I mean, the length of her shadow, I mean, it's very hard to draw this out on screen without being able to point, but this tip, the length is getting smaller, and this tip would be moving this way as she walks, and the length of the shadow would be decreasing. So I'm gonna just add in a third variable. I'm gonna say that this whole thing, and I hate to do t for tip because I don't like dt, it's confusing even if I do a capital. So I'm just gonna, I'm gonna pick just another letter. At what rate is the tip? I'll put a P because tip has a P in it. Or for Pruitt, either one. Okay, anyway, so here's the deal. Look at the relating equation. X plus L is equal to P. Now what are you looking for in part B is dP dt. Well gosh, that's a pretty easy equation. The derivative would be even easier. Dx dt plus dl dt is equal to dP dt. Well, you know dx dt is negative 3. You know dl dt because you just figured that out, and you have to put it as a negative. And so you end up getting that dP dt is negative 14 over 3. So you can say the tip of her shadow. Now again, here's some interpreting. The tip of her shadow is getting closer to lamp. At a rate of 14 over 3 feet per second. Now, again, the fact that I said getting closer to the lamp, that interprets the negative, that this tip is moving this way. I could say the tip of her shadow is moving at a rate of negative 14 over 3 feet per second, but I like to do an interpreting step because many times they ask you to interpret it, so you have to understand what these numbers are meaning. So again, look at all that I did. I did 3 problems, really 4 because there was A and B, none of which I used a calculator. And I was able to find those values. They were a little more complicated, but now that you've seen them, hopefully you'll be able to do the homework. So work very hard on those, and that'll be good. All right, have a good one.